Welcome to EC&M Tech Talks, and today is all about optical fiber cable. Fiber optics. We're going to go out and run some fiber or whatever it is, okay? All interchangeable terms that we use out in the field. So the first thing we want to do is we're going to look at what fiber optics is and why we even use it. Then I always find it a little easy to understand. If I have to go out and do something, install it, work on it, whatever it is, if I can understand what it is I'm working on and how it works and how it operates and all of that, then I have a lot better, more confidence, I guess you could call it, when I have to go out and do the work on it. So anyway, we're going to take a look at some of the basics. And then we're going to get into the code rules for installing fiber optic. And that is that is Article 770, which is optical fiber cables. But as I say, we often just call it fiber optics or maybe even fiber cable. So we're going to take a look at some optical fiber cable in, because that's what Article 770 is all about. We're going to see how it's constructed, the different types of optical fiber cable, and because that's going to affect how and where we're going to install it. Then we want to get into the rules of the NEC for installing fiber optics. And finally, we'll wrap up with a little bit of talk on splicing and terminating, some things that can help you to get started in that area. So anyway, the 5 sections that we're going to cover then, we're going to do our introductions to optical fiber. We're going to take a look at our NEC definitions. And that's important because that's also going to lead us into hazardous classified locations where we can use this fiber optics. The types of fiber we install is Section 3. That's Article 770 and what it's all about. And so we'll get in then in Section 4 into Article 770 and learn how we do it, what the rules are, what types of fiber we can use where, and so forth. And then finally, as I say, in Section 5, we'll wrap up, and I'll give you some little heads up what you need to do if you want to get into the world of splicing and terminating this fiber optic cable. Now, why do we even use fiber optics? And I think we probably pretty well know, that it's higher bandwidth, right? We can transmit much more data at higher speeds, so that's a good thing. We've got capabilities of long distance transmission over the long haul, as we might call it. And it's fiber optics. It's not electrical current flow, so it's immune to electromagnetic interference. Makes it more reliable. Security-wise, it's good. It's harder, I suppose, to tap into fiber optics, they tell us, in copper-type data cabling. It's durable, it's long-lasting, it's made of glass, silica, plastic, whatever, but it's a glass core fiber we're going to take a look at. It's generally more durable than copper cables, especially in harsh environments. So, durability, longevity. It's also lightweight, it's very thin. We'll take a look at some. And this is actually called zip cord. And it's very light and flexible. It looks like something I might have on a lamp cord, but it's not. It's not copper on the inside then. And it's going to require less power consumption. So that's always a good thing these days, isn't it? So let's talk about the major components in the system. Certainly we have to have a transmitter. And what the transmitter is going to do is going to convert the electrical digital signals into optical or light signals, pulses of light then. The light source, it could be a diode, it could be LED, and that modulates the light to encode the data and send it on down the cable. The optical fiber cable itself is the medium, of course, that transmits. So we have the transmitter, we have the cable, and then it's got to go somewhere, right? And so it goes to the receiver on the other end. We might find the optical amplifiers. They're used to, in long distance applications, to boost the strength of the light signal without converting it back to electrical signal. So you can see the advantages of that. You might run into an optical receiver, certainly. There are going to be connectors and couplers along the way, and different types of connectors and couplers and so forth, depending on your application, your needs, what you're going into, and with your cable and the particular cable that you're using then. You might hear the term multiplexers or demultiplexers. And what a multiplexer is, it's anything that's going to allow us to provide multiple wavelengths, in other words, different data channels to travel together on a single fiber. And so that's pretty handy. It increases my bandwidth, doesn't it? We have optical amplifiers. Of course, the receiver itself converts the light signal back into the electrical signal so it can be interpreted by the end devices and come up on the computer screen, audio, video, whatever it is that we need. We have, as I said, connectors and couplers along the way. Optical switches is another term you will hear. And this is a device we go into and we can take and route the optical signal from one fiber path over onto another one. So it's a switch. Right? Those are some of the terms that you're going to run into, and we'll introduce some new ones certainly as we go along. NEC definitions. Let's move into section 2 now on NEC definitions. There are 4 definitions in the NEC regarding optical fiber systems. And we can find those in Article 100, of course, where all of our definitions are now located. There is a definition for optical radiation. You can read it and interpret that for yourself, all righty? But what I want to get into is the 3 more definitions that follow that one that regard our optical fiber systems that certainly apply to our National Electrical Code, certainly in Chapter 5, and hazardous classified locations then. So this is a big boom then for using optical fiber. Now, we're familiar with terms probably like explosion proof, intrinsically safe, purged and pressurized, and so forth. And these are all types of protection techniques. In other words, they help to either contain the explosion itself that could occur and then allow the gases and vapors to escape safely into the atmosphere after they've cooled down. It might be intrinsically safe. There just isn't enough energy to cause any type of explosion and so on. Purged and pressurized, we keep the gases and vapors, the bad gases and vapors, right, out of our equipment through the process of purging and then pressurizing that equipment and so on. So several different protection techniques. Now there are 3 optical systems that offer different protection techniques as well. And I can use them in either our division classification system, like probably we're most familiar with, like Class 1, Divisions 1 and 2, for what I call the bad gases and vapors, right? And also we can use them in our zone classification systems. So if we take a look in Article 100, we find those 3 definitions. And the first one talks about, well, you'll have to look under optical radiation, comma, inherently safe. And it's the term for it is OPIS. And it's called inherently safe optical radiation. And it's just what it means, inherently safe. There's just not enough energy there from that infrared radiation to ignite any specific explosive atmosphere. So all the details we're going to find after the definition then for using that system, we'd have to go into Chapter 5, wouldn't we? Articles 500 and 501, and find out the specifics for using these protection techniques in hazardous classified locations. I also have another type where I can find the visible or infrared radiation inside the equipment in the system, which is normally what should happen, right? The radiation stays on the inside of the cables in my devices and equipment and so forth and doesn't escape into the surrounding atmosphere, so thus cannot ignite any flammable gases, vapors, things like that. Now, we call that protected optical radiation. So in your definitions, it's under optical radiation, comma, protected, and then you'll find it's designated as OPPR type of protection technique. And then finally, what if it does get out? That's the big question, huh? And so we have something called optical system with an interlock, or OPSH. Okay? And it's the, normally the beams are confined, as we talked about, the infrared and so forth. But there's an interlock if I should, what if something should escape? I want that interlock system to reduce that beam strength down to a level that's safe for that environment, or maybe cut it off completely, whatever. So that's called an optical system with that cutoff interlock. Let's look at the types of fiber optic cable that we install. Probably the best way to do that is let's go in your code book. Let's go back to Article 770. And of course, I'm going to be using the 2023, the latest edition. And in the 2023 edition, that starts on page 677. But whatever edition you use, let's go ahead and use that. Okay? Or you go ahead and use that. Okay? I'm in the 2023. And if we turn to page 683, so if you go to page 683, you're going to find table 770.154a. And it's titled Applications of Listed Optical Fiber Cables in Buildings. And until you understand what this table is telling you, it's confusing. You may not be sure what you're doing. If you take a look at this table, down the left-hand column are different types of locations. For instance, the first location, it says in ducts specifically fabricated for environmental air as described in, and it says in Article 300. So it talks about environmental air. The second grouping down says in other spaces used for environmental air, such as plenums, as described in Article 300. So plenums. So environmental air and plenums. Stop and think about it. Environmental air. If I do have some fiber optic cable that were to overheat, catch on fire, there's a fire in the building, I don't want those products of combustion. As this cable burns, I don't want any bad vapors or particles, whatever it is, given off from this insulation or jacket, actually, on the outside. I don't want those bad fibers or those bad particles from the jacket then to spread throughout my environmental air distribution system. Because why? I've got people in the building who are breathing the environmental air. So that becomes an issue for me, right? So I want to make sure that I'm going to use the proper type of cable that can be in that environmental space. Now, another consideration down the left-hand column in this table, 770.154, is risers. It also gives the location of risers. What's the difference with a riser? A riser goes up vertically, doesn't it? So what I'm concerned with is my fiber optic cable, and a riser is there going to be any flame propagation should this stuff start to burn? Is this going to try and propagate any flames on up to the next levels in my building? So the two areas, environmental air, I don't want those products of combustion to be inhaled by people. So I've got to use the right type of cable for that location. And then the other is in risers, in vertical runs, I don't want those flames to be propagated on up throughout my building. So I have to use the right type of cable in those riser locations as well. And then finally it says, well, the last location, it says within buildings other than air handling spaces and risers. So buildings other than air handling spaces and risers. So that's anywhere else in the building. So now I have to run maybe from my IT room or whatever I've got in my home, right? And I have to run to an outlet on the wall. And so all of a sudden, it's not as critical, is it? So across the top to the right of that first column then, it gives me my applications, and then it lists the different types of fiber optic cable. Notice all those different letters, OFNP, OFNR, and all of that. What do all of those mean? Well, OF means optical fiber, so they all some type of optical fiber in OF. The N means that it's non-conductive, so there's nothing that's electrically conductive inside the construction of the cable. And then OFC would be something that is conductive. So there's some of our cables we're going to take a look at. Oh, this one right here. We're going to find there's some metal components. It almost looks like type MC cable. We'll take a closer up look at it later on. But there's some metal components in there. And so that is considered conductive. R would mean it's riser cable. G would mean it's general purpose. P would be for plenum. So if we take a look across that first row, we'll look at it up on the screen. It says that if I'm going to use some, I need to choose some cable in a duct or used for environmental air, okay? And so that's that very first row that I run across. And ducts specifically fabricated for environmental air. I read across, it says, what's the application? And fabricated ducts in metal raceways that complies with Article 300. So I have some fabricated ductwork in my overhead, and I need to run some optical fiber cable through it. What can I use? And in that very first column, it says, yes, I can use OFNP, optical fiber, non-conductive plenum-rated cable, or I can use OFCP, optical fiber, conductive plenum-rated cable. Can I use optical fiber, OFNR, non-conductive riser? No. How about OFCR? No. And then I can't use anything out of that last column as well, huh? Not even some OFCG, some optical fiber conductive general purpose cable then. So I pay attention to that. That's very important, obviously, because of what we just talked about. We're talking about human beings and life and health and so forth. So we pay specific attention to that table. Now, what if I want to substitute? Do I want to substitute another cable? And the answer is yes, I can do that. So if you turn over to the next page, you'll find table 770-154B. 770-154B is cable substitutions. So for instance, if I'm going to use OFNP cable, there is no substitute that I can use other. If it calls for OFNP, that's what I got to use. On the other hand, if it calls for OFCP in my application, a permitted substitution is OFNP. So pay attention to that one as well. Okay. And so next in this section, let's take a look at some fiber optic cable and figure out what the heck's going on with it. And so taking a close-up view, here is some OFNR cable, fiber optic cable. It says on the jacket OFNR, which means that it's optical fiber, it is non-conductive, there's no metal components on the inside, and it's suitable for use in riser applications. This feather-looking stuff out here, that's aramid fiber, and it's very strong. So I can actually take it, once I get it separated, I can take and curl it up and use that to pull my fiber optic cable if I need to. This particular fiber optic cable has 6 different glass core fibers in it. Each one is covered with a plastic jacket, and they're color-coded, which of course is very important when I start terminating and working with it. Now, if I strip the jacket off, and I need special tools to do that, I find the glass core. How big is the glass core? Well, it has a metal cladding, or excuse me, not a metal, it has a glass cladding around the glass core. And the whole width of it, you know, we're talking basically, it's measured in microns, but it's basically about a human hair, sometimes less. So I can get these in different diameters as well, the different glass fibers. So in order to strip and terminate these, I need special training to do that. At the end of the video, I'll give you some resources for that. Now let's take a look at another type. This is a direct burial, and I stripped the jacket back on this. Actually, it's kind of nice because there's 2 grooves, one on each side of the jacket, and I can take and cut through those grooves and then just pull the jacket back. I reveal the metal cladding underneath. This is corrugated metal cladding. Kind of looks like a tape. You actually peel it back and peel it off of there. Underneath the metal, corrugated metal, there is a very clear plastic covering. Looks like the Mylar sheath, maybe it is, you know, that we have for our type MC cable. There's also a little orange string right there. That orange string is right underneath that clear plastic sheath. We call that the ripcord, and I can grab a hold of that ripcord and pull it back, and then that opens up that sheath for me. Otherwise, it can be pretty tough to get off. All of the white that you see, this is all just filler material for the inside of the cable. The corrugated sheath protects me from physical damage. Also, if any rodents try and chew through it, as they love to do, it seems like on cables, and the fiber optics on the inside is going to be protected by that corrugated sheath. So where are the fibers? Well, they're actually inside of this blue tube. And that blue tube, that's called loose blue tube construction. And this has 12 fibers on the inside of it. The 12 fibers are passed through the tube, and this one is a non-gel filled. The manufacturer needs to keep water from ever getting inside of that, and so they can put a gel in there. This is non-gel filled, so it has some type of material that expands if water should get into it. And so there are 12 color-coded jackets, really tiny, and we'll talk a little bit more about safety when it comes to terminating these. So that's a little bit of an overview then of the construction of the fiber optic cable. And now let's return back to find out a little bit more about the cables, where we use them, and taking a look at Article 770 and so on. And now that we have a good handle on the cable itself and the different types of cables and where we use them and so forth and what all this fiber is doing and how it's constructed, now the rest of Article 770, optical fiber cables, should make some sense to us. So let's round this out with an overview, look at some of the highlights out of Article 770. Part 1 is some general information. Some important topics here. 77.24 says that all optical fiber cable must be installed in a neat and workmanlike manner. You say, oh, that's wrong, Randy, that changed. That's changed in this edition of the code. We don't use that term anymore, neat and workmanlike. It's something about professional or whatever, okay? Back in Article 110. No, it didn't change in Article 770. So we're required to install it in a neat and workmanlike manner. And there's some specifics on that. One thing is that we have to be able to allow our suspended ceilings. If I walk in and I push up that suspended ceiling, I want to have enough room to move that ceiling tile out of the way, get up on my ladder, get up there and do some work if I need to. I don't want that fiber optic cable down right on top of that suspended ceiling then. And it gives some other details in 770.24. 770.25 says I have to remove abandoned cables or tag them for future use. 770.44 appears in Part 2. So now we're talking about in Part 2 is cables outside and entering the building. And so it covers the rules. 770.44 covers the rules for overhead, and then we'll see some rules for underground. On overhead, and you probably don't get into this, or some of you do, I'm sure, but if you're going up on a pole. So if you're going up on the pole and you've got that cross arm up there, only those light and power conductors are going to be on that cross arm. Any of that communication cable, that fiber optic, is required to be below that. The distance is based on the voltage of my overhead conductors on the cross arm, and I can't attach ever those that fiber optic cable to that cross arm. When I go across, if I'm stringing this across over a roof, wherever the highest part on that roof that this goes over, this fiber optic cable must be at least 8 feet above that. And of course, as usual, there are always exceptions. So once again, the importance as we go through Article 770, always pay attention to your code, especially the exceptions. They can save you a lot of work sometime. And also remember the notes. The notes are part of the code. The notes in the tables are part of the code. Informational notes are not. They're just there to give you some helpful information. So read your code books for all the details. Okay? Dot 47 is rules for underground fiber. And so if we're running with light and power cables, the general rule is we've got to have a certain amount of separation. And we may need a physical barrier in there, most likely. So that's going to be specified by dot 47, and it's going to give you some ideas on what you can use. So I have to have a physical barrier to separate the two systems, and my direct burial fiber must always be separated by at least 12 inches from the light and power cables. But when I come into that manhole, if I'm coming in with both light and power and my fiber optics, I've got to put my barrier in there. Part 3 gets into protection. And it's a very short part 3, but it talks about grounding and bonding requirements. So if you think about it, A lot of fiber optic cable, we said this was in non-conductive, OFN type fiber optics. So if it's non-conductive, there's nothing to ground to here. But on the other hand, this particular cable has a corrugated metal sheath wrapped around it, as we saw in the close-ups, and so that's metal. We've got to bond to that. It could become energized during operation, and so we need to bond that to our distribution system then. So that's what part 3 tells me. Then it moves into part 4, which is the grounding methods for entrance cable. So when I do bring this cable into the building, what do I have to do with it? So we're going to have to bond that metal sheath. And it also, by the way, this section also references me back to 250.94. 250.94 we'll talk about in just a second, and that's for bonding of communication systems. So anyway, 770-100. If I have to bond to this cable, what I'm going to do is, there's like a wedge, and I'm going to take and slip that wedge between the filler and that metallic sheath. And it's going to clamp down on that metallic sheath then. And when it clamps down on that metallic sheath, I tighten the bolt down, sticking up on the stud. I can attach my equipment grounding conductor, a bonding jumper really is what it is, right? And I attach my bonding jumper, and from there we have to get back to 250.94, and we have to take that bonding jumper from where we enter the building, and we have to take it to our intersystem bonding termination. So the intersystem bonding termination, here's my service panel. My service panel, I've got my grounding electrode conductor that runs out of my service panel, and my grounding electrode conductor, of course, goes to the grounding electrode itself. The intersystem bonding termination device, different types, different manufacturers. This particular one is attached to the box with the lock nut, and then there's a set screw on the front of it that's tightened down, and that attaches it firmly to this grounding electrode conductor. Then I have what? 1, 2, 3, 4, 5, 6 areas where I can, or 6 terminals where I can bring in my intersystem bonding conductors, where I can bring in my bonding jumper from my metal sheath and attach that bonding jumper here to my intersystem bonding termination. Then what does that do? That then places this metal sheath at the same potential as my grounding electrode conductor, the earth and ground that I'm standing on. So that's a pretty important connection. Now there are rules. Let's say that my intersystem bonding termination, that intersystem bonding jumper, it works out, they're not close together. Usually we're going to terminate our communication cables at demarcation point, we call it, where the utility connects to our premises communication wiring. That's going to be close to the service somewhere. But if it's not, if it's more than 20 feet away, then I have to what? Over here where I terminate my communication system wiring, I'm now going to have to drive a ground rod at that point. And I'm going to have to use a minimum 6 AWG conductor bonding jumper to run from this ground rod to the ground rod over at my service. So that's that 20-foot limitation. Now, the minimum size of my equipment bonding jumper to run from my sheath, metal sheath, over here to my intersystem bonding termination is going to be 14 AWG. So you can find all of those rules then in 770.100 and Part 5, Grounding Methods of Entrance Cable. Also, some other things that we're going to find in Part 5, it's specifically actually in 770.100, it says, you know, some basic things like run my conductors in a straight line, provide for physical protection if needed. It tells me, it refers me to 250.70 as to how I make my grounding and bonding connections, which we just go back to Article 250, it says for that. Now, big question is, what if I don't have? 250.94 says I have to have an intersystem bonding termination here. But there's an exception in 250.94 that says, no, in existing dwellings you don't need one. Well, because we don't have to go back and modify it, do we? Oh, well, great then. Now I install my cable. It's got the corrugated metal sheath. I need to run an intersystem bonding termination, but where do I connect it? So in 77.100, we're going to find that there are 7 different locations of where we can connect it to. Perhaps it's the enclosure for our service and so forth. So anyway, if you get into that situation, which you may well if you're installing this cable, then take a look, close look at 770.100. Lots of rules in there, righty? If I'm going to a mobile home, that's a little bit special. 770.106 is your rules for entrance cables to mobile homes. Part 5, installation within buildings. Well, we've already taken a look at the table, haven't we? So we understand what types of, that's at 770.154 A and B. So we understand what types of fiber optic cable we can run where inside of our buildings. Now, 770.110 talks about what types of raceways, cable routing assemblies, and cable trays. Well, we can put this fiber optic cable in any of our raceways that are back in Chapter 3. We can put it in cable tray. In fact, if we go to Article 800, which is our general requirements for communication systems, we're going to find that there is a listing, there's a table, big table, that lists all of the different cable routing assemblies that are approved that can be used for this fiber optic cable then. So that's in Article 800. Part 6 is my listing requirements. It's all got to be listed. And also, even I described that wedge that we would use for bonding that would slip underneath the corrugated metal sheath in this example. That wedge must be listed as well. So we're going to use listed components then for the installation of our fiber optic systems, and of course the cable is all listed as well. So that moves us into Section 5, which is terminating and splicing of this fiber optic cable. Now, before we even talk about terminating and splicing, when you get into it, you're going to be exposing that fine fiber optic core with the cladding hunter, right? And we're talking about the width of a human hair or so, something like that we say. And so very fine. The problem is that glass can become embedded in your skin. It's very sharp on the end. If you poke your skin with it, it'll go right into your skin. And being glass and very brittle, it'll break off. And now you got a piece of glass underneath your skin. And that's not going to be easy to get out if you can. And it may take some time, and it's going to be painful. You don't want that. So always, always follow your rules, your safety rules. Wear glasses, wear your safety glasses. If you want to learn how to put these terminations on the end, you're going to need to take some special training to do that. You're going to need the special tools. You're going to need a cleaver to cut the cable. You're going to need a special device. As fine as that jacket is on that individual fiber, you need some type of tool that'll take that jacket off and not damage the glass. You're going to need to clean it. Boot on there, and then put whatever type of connector you're using on the end, and then you're going to have to put it into a special device to lock that fiber optic core and cladding into that connector. This is not something you're just going to do out in the field casually. It's got to be done in a clean environment. You know, you don't want dust, you don't want oil and grease and things like that. If that gets on this cable, you contaminate it. If dust gets in the connector, you got to start all over again and so forth. So you need some special training on that. If you'd like to move forward then, now remember, because Article 770 only talks about how to install our fiber optic cable. It does not talk about how to splice it and terminate it. So where do you go to learn how to do that? Well, some different resources for you, and you can, get online and look this up, but there are certification programs. And so perhaps you should look into some training and even certification within some of these organizations. There's the FOA, of the Fiber Optic Association, FOA. BICSI, the Building Industry Consulting Service International, BICSI. They also provide certification. The ETA International, the Electronics Technicians Association, also provides certification. So all of these organizations, they require training, and you demonstrate your skills and your knowledge on this this fiber optic terminating and splicing and so forth, and then you become certified. Also take a look at your individual manufacturers. Several of the manufacturers have their own training on how to use their equipment and how to use their cables and splice and terminate it. So that's all the information we've got for today. As always, it seems like we never have enough time. We barely scratched the surface, and boom, it's time to go. So until the next time, work safe.